video is going to discuss factoring polynomials. Let's take a look at this equation. These two polynomials on the left are called factors of the polynomial on the right. Figuring out what these factors are of a polynomial, that's called factoring. When we look at factoring, there are some special products that have been given names because of their form. So we're going to take a look at all of these before we get into some examples. These would be great for your notes. The first is called the difference of two perfect squares. Here I have x squared and a squared, and you can see that it can be factored by x minus a, x plus a. The next set is a sum or a difference squared. You can see it's x squared plus 2ax plus a squared. The only difference between the sum and the difference is that first sign. Another set of special products that's good for your notes, cubes. So cubes of binomials or perfect cubes. You can see here in 4a and 4b that when you have x and an a, either added or subtracted, cubed, this is your result. Another pattern we have here is the difference of two cubes. So if I have x cubed minus a cubed, this is what it's going to factor and look like. And lastly, we have the sum of two cubes. So just like in the difference of two perfect cubes, this is what the sum of two cubes will look like. Now let's look at an example and see if we can figure out how to factor these polynomials. The first polynomial is going to be x to the fourth minus 16. First, let's get our notes and our list of all of the special products that we just discussed. Looking through these, we can see that this looks most like x squared minus a squared. We can rewrite the polynomial as the difference of two perfect squares by saying the x to the fourth minus 16 equals x squared minus 4, x squared plus 4. Not quite done yet because x squared minus 4 also looks like the difference of two perfect squares. So using the same method we did before, we can write it as x minus 2, x plus 2. Now we're done. If you want to see more examples of how this works, take a look in your book at page A28. So completing the square is an idea that you can actually create the difference of two perfect squares just by adding a number to both sides of your equal sign. There are 3 steps. So first, you're going to identify your b, and your b is going to be the number or the coefficient that is associated with your x. Next, you're going to divide b by 2 and then square whatever that result is. Last, you take that value and add it to both sides of your equal sign. Your factored result is going to be x plus b over 2 quantity squared. Here are some examples from your book on page A29, example 10. I'm not going to go through all of them, but you can see here for the first one, y squared plus 8y. In order to complete the square, I'm going to find the coefficient 8, divide by 2, which equals 4, and then square that, which is 16. Once I know that, I can add 16 to both sides of the equal sign and find that the factored form is going to be y plus 4 squared. You will work through some of these other problems on your own time.